All right. So when we convert from degrees to radians, we have to think about the relationship between these. So 180 degrees is equal to pi radians. Okay? So that means I have two conversion factors that I could use. I could say 180 degrees compared to pi, or I could say pi radians compared to 180 degrees. I don't like that last one. So if I have a bunch of numbers, like let's say I want to convert 315 degrees, I'm going to multiply it by one of these conversion factors. Well, since I have degrees on top, I'm going to choose the second one because I want to cancel out the degrees. So I'm going to say that is going to be multiplied by 315 times 180. So I've got 315 over 180 degrees times pi. Now, notice that I didn't put the degree symbol down because technically this degrees, this will cancel with this. That's why we chose the second conversion factor. We want that to cancel. If we were to convert from radians to degrees, you would use the first conversion ratio and then the radians would cancel. Radians will always have pi in it. So now what I got to do is I just got to simplify this equation, or simplify the fraction. There's a little trick. Most of the time, this will be divisible by either 30, 15, 60, or 45. I think 45 goes into both of them. So let's see. If I turn on my calculator and I say, is 315 divisible by 45? Oops. Let's see. Yep, 7 times. Is 180 divisible by 45? Yeah, 4 times. I've kind of memorized this. So that means that if I take this 315 and I divide the top by 45 and I divide the bottom by 45, it's legit as long as I do the same thing to both the top and the bottom. Then I get 7 over 4 times pi. And sometimes you'll see it written like this, 7 pi over 4. Well, now let's do another one. So anyways, this problem, you got to convert like 4 of these. So the next one is 80 degrees. 80 degrees. Same conversion ratio, I'm going to say pi over 180. Well, this one isn't, 80 isn't divisible by 45, but they're both, it looks like they're both divisible by 20. So if I divide this by 9, and I divide this by, not by 9, by 20. Whoops, my bad. And divide this by 20, I get 4 pi, because 80 divided by 20 is 4. 180 divided by 20 is 9. So I get 4 pi over 9. If I get 225, same conversion ratio, pi over 180 degrees, that gives me 225 over 180 times pi. I think they're both divisible by 45. So I'm going to divide this by 45. And I think that's 5 times pi. In other words, 225 divided by 45 is 5. 180 divided by 45 is 4. So that's that one. This last one's a little tricky. We've got 324 degrees. Why do my hand just makes it 2 for some reason. Same conversion ratio times pi over 180 degrees. The degrees cancel. I get 324 divided by 180 times pi. Well, they're both divisible. So this is an interesting one. They're both divisible by 4, I think. They might even be divisible by 6. So 180 is divisible by 3, divisible by 6, divisible by 4. So I'm going to try, let's see. So if I say 180 divisible by 9, it's 20. I got it. Well, let me back up. I got to do 324 divisible by 8. Is that divisible? Well, no. I want to do the same thing. Let me see if it's divisible by 9. Yeah, it is. So what I'm going to do is if I divide this by 9 and I divide this by 9, what was that? It was 36. So this then becomes 36 over 20. So we got 36 pi over 20. Now, if I look at that, they're both divisible by 4 again. So I'm going to divide this by 4, divide this by 4, and I get 9 over 5, and then I just tack on the pi. And then that is basically it. So those are 4 problems that